All right, let's continue learning about logic. And we're going to start with this very, very important central concept to the course, validity. When is an argument valid? Well, let's just start with the technical definition. Well, I don't want to be careful here. It might not make sense when you first hear this technical definition, but we will work through it slowly and surely to make sure that you do understand. Validity. An argument is valid. Again, this isn't a typo. If and only if it's impossible for the conclusion to be false, given that the premises are true. So remember when we were figuring out if an argument is deductive or inductive, the method that I suggested that you use was to grant that the premises are true and then ask yourself, does the conclusion follow? Does it follow absolutely or necessarily, or in terms of probability, 100%? Is it guaranteed? And if it is, then we say the argument is deductive. If it's not, then the argument is inductive. If it's not deductive, at least for our class, we'll say that it is inductive. There might be some logicians, some textbooks, instead of, they might have other categories and they might say, oh, there's deductive and non-deductive arguments. And that would be a fine way to carve things up too. But for our class, every argument's deductive or inductive. So if it's not deductive, then it's inductive. All right, what exactly is this saying? Well, if you look at an argument and you grant that the premises are true, and you look at the conclusion, you're like, wow, if I grant the premises, the conclusion is guaranteed. If that happens, the argument is valid. And if it doesn't, the argument is not valid. We'll say invalid. And another way of saying that is, if you've got a valid argument, given that the premises are true, the conclusion has to be true. And if it has to be true, then it's impossible for it to be false. So notice that those are two different ways of saying the same thing. I'll say it more slowly and I'll say it again. If the conclusion has to be true, then it can't be false. Doesn't that make sense? You can pause the video if you want. If something has to be true, it can't be false. Doesn't that sound right? Okay. So if the premises are true, if we grant that they're true, that's why it says given, assuming for the sake of argument that they're true, given that they're true, if that guarantees the conclusion, that means the conclusion has to be true, then it's impossible for the conclusion to be false. And by the way, this IFF, it's a shorthand for if and only if. Here's another way to think through validity. Grant or imagine that the premises are true. Hey, and if they are true, that should be easy, right? And then ask yourself, is the conclusion guaranteed? The answer is yes, the argument is valid. If the answer is no, the argument is not valid. So for instance, premise, no dogs are cats. Does that sound right to you? It sounds right to me. So we're going to imagine that that's true, which is easy because it is true. No, cats aren't, they're different kinds of animals, obviously. Okay. So if I concluded that no cats are dogs, would that follow? So all I did is I switched around the order here. I said, look, no cats are dogs. Why? Because no dogs are cats. These are different ways of saying the same thing. And whenever you have two statements that are synonymous like that, you put them in an argument where one's the conclusion, the other's the premise, then the argument's going to be valid. Let's do a few more examples. Let's go back to 1.3 and look at some of these deductive arguments. And we'll see that they're valid. Like 12 here. This is a valid argument. Remember, this is that it's either this or that, and then you rule out one of them, so the other one must follow. What was the origin of classical culture? Classical culture, did it originate in Greece or Egypt? Let's say it has to be one of the two. It's like, let's say you're a history major and you're like, oh, I got this, but I kind of forget. But I know that it's Greece or Egypt. And then if you rule out Egypt, then it must be Greece. That's a valid argument. So if we are given that these premises are true, then this conclusion has to be true. It's guaranteed. And if it must be true, it's impossible for it to be false. It would be impossible for classical culture to not have originated in Greece, given these premises. That's what validity is all about. Same thing for 14 here. The form of this argument is sometimes called, well, this is I shouldn't maybe throw this Latin phrase at you just yet, but I will, since you've caught me almost accidentally bringing it up. But the form of this argument has this Latin name because these ideas in logic are so old that they were studied and written about when people were writing and speaking in Latin. And so this argument type or form is so prevalent that it was given a name, and that name is modus ponens. I'll say that a million times in other video lectures, so don't worry about it for now. But the structure has an if-then statement in it. If blank, then blank. The blanks don't have to be the same. If A, then B. If something, then something. If Musk is right about AI, then AI is a risk. And then there's another premise that affirms that condition, that part that's attached to the if. If it is right about artificial intelligence, okay, well then what follows is the second blank, is the part after the then. Well, then it really does pose a risk to human survival. Again, this argument might not be good. We don't know if these premises are true, but the argument is valid. Now, this confuses some students because in everyday conversation, you might use, maybe not validity, but you might say a point or an argument is valid. And outside of a class like this, what usually is meant by that is that the point or the argument is a good one. But in this class, we're using this term in a more specialized way. So it doesn't just mean you made a good point or your argument is good. It means something more specific than that. And it means technically this. Remember when we talked about evaluating an argument? We said that there's two things that you can look at when you're trying to figure out if an argument's any good, when you're trying to evaluate its merit. You can look at the inference and you can look at the actual truth values of the premises. And if the argument is good, then you want a thumbs up to the question, are the premises actually true? You want the premises to not be hypothetically true, but be true, period, in this world, actually true. And you also want the inference to be good. You can think of the inference as the bridge or the glue that connects or binds the premises and the conclusion. When there's a good inference, you have support, either probabilistic support, which we said was inductive, or logical support that is absolute. That's the word I was looking for, which is deductive support. So what would be an example where the glue is there, but the premises are actually false? Well, change California to Florida. I, Ryan, live in Florida, therefore I live in the United States. Notice that the premise is false. I don't live in Florida. I live in California, like many of you, probably all of you. But the inference, the support is there, because when you look at validity, this part of the definition doesn't say the premises are actually true. It says given that the premises are true. And if you are given that I live in Florida, if you follow this tip and you imagine that the premise is true, here, if you imagine that this said Florida, if you imagine that, then it would follow that I live in the United States. So that argument is valid, but it's not a good argument overall because it has a false premise. This one, it says Florida, but if we change this to, it says California, but if we change it to Florida, this argument would be valid, but it would not be good. Put it back. So if you have both of those components, if you have both of those ingredients in your recipe, if you have a valid argument and you have all true premises, then we will say of that deductive argument that it is sound. So a sound argument is a good deductive one. Now, if you have all true premises and the inference isn't valid, but it's inductively good, then what do you got? Do you have soundness? No, we'll have another name for that, which is cogent. Now, I've thrown a lot at you, and there's this graphic in the text, which I think summarizes it all. So this is a very, very helpful slide. So we start out here with statements, and in the supplemental reading, we learn that it depends on who you ask about statements, but for many people who do logic, statements and propositions are synonyms. They mean the same thing. And they are the content, they are the meaning, the semantics of declarative sentences. So when we're talking about statements, we're not talking about questions or commands or exclamations. We're talking about the meanings of declarative sentences. And by definition, those are either true or false. Now, we know an argument is a group of statements, but are all groups of statements arguments? No, of course not. You could have a group of statements that's a poem, right? A poem could be a bunch of statements. Doesn't have to be all statements, but it could be. And not all poems are arguments. Sometimes you are explaining something and you're giving a bunch of statements. You're not arguing something, you're explaining something. So there's a lot of things that are groups of statements. They're not arguments. The ones that are, we said, well, all of them are either deductive or inductive. And so in another video, we learned how to differentiate the two. So now once you get to deductive arguments, these are going to be valid or invalid. And we learned what validity is. So I think the easiest way is you just grant the premises, imagine they're true, which is, whoops, I'm on the wrong tip here. Imagine they're true, which is easy if they are, and then ask yourself, is the conclusion guaranteed? If it is, then you got a valid argument. And if the answer is no, then the argument's not valid, it's invalid. Now, if you add to validity all true premises, then you get soundness. That's very special. This is a sound argument. Again, there's the implicit premise that California is in the United States. That's true. I live in California. That's true. And those two statements guarantee that I live in the United States. So that is a valid argument. It's a deductive, it's valid, and it's sound. And if you change California to Florida, then the inference would still be good. It would still be valid. It would still be deductive, but you'd have a false premise. And so it would be deductive, it would be valid, but it would not be sound, because for soundness, you need all the premises to be true. But I don't live in Florida, so it can't have all true premises, so it can't be sound, so it'd be unsound. Now we can also split inductive arguments, but instead of saying of them that they're valid or invalid, what we will say is that they are strong or weak. So if you think about this in terms of percentages or probabilities, if imagining the premises makes it 100% likely that the conclusion is true, that's a valid argument. If imagining the premises are true means that the odds are between 50 and 100%, then we will say of the argument that it is strong. So you imagine the premises are true if you've got an inductive argument. And if then you ask yourself, is the conclusion likely? given these premises that you've granted. And we'll define likely as between 50 and 100% likely to be true. And again, we're not counting 50 on the dot. We're not counting 100 on the dot. 100 on the dot, that's validity. And 50, it depends on how you want to define strength, right? You could be really narrow and have a high bar of strength. You could say, no, it's got to be 66% or 75 or 80% for it to be strong. But we'll say if it's more likely than not, which means that's more than 50%, but not 100%, then we'll say that it's a strong argument, strong inductive argument. And if that plus all true premises, boom, that's going to get us cogency. And if your argument is inductive, but the conclusion isn't likely to follow, we're going to say of that is not strong, and then it's weak. So if the odds are 50% or less, then we'll say of it that it is weak. By the way, all invalid arguments have to be unsound because soundness requires validity. And all weak arguments, by definition, are not or are uncogent because cogency requires strength. All right, that was a lot, but let's practice. And that's what we are going to do in 1.4. Validity, truth, soundness, strength, cogency. And so you've watched, hopefully, what I just said, and you've read through all this, and there are examples and definitions and wonderful tables. This is a great table. This goes through all the combinations because we have categories of valid and invalid. So an argument can vary on that dimension, but they can also vary when it comes to all true premises, or there are some false premises. And there are also going to be variation when it comes to the conclusion. So look at all this. Unsound, 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 unsound. Soundness is rare and special. Everything, it's like the perfect storm. Everything has to go right. You need the argument to be valid. You need all the premises to be true. Then you'll have soundness. You can think of validity in terms of truth preservation. So some philosophers talk about truth preserving arguments. What does that mean? Well, think about an argument, think about its premises like inputs, and think about the conclusion like an output. Like a vending machine. What's the input? Dollars or coins, or I guess cards these days. But in the old, like when I was a kid, at least, probably you guys too, but put some coins in the vending machine. That's the input. And then what's the output? Whatever selection you made, right? A bag of chips, a candy bar, or whatever, a Coke, or whatever it is. Apply that to arguments. The input is the premises. And if those premises are true, if the input is true premises and the argument is valid, then the output has to be a true conclusion. And so valid arguments preserve truth. If you input truth, you're going to get truth. You put in truth, you're going to output truth in a valid argument. And so that's why the conclusion has to be true. Now, here's what's trippy, or here's a question. Could you have true premises, true conclusion, yet fail to have validity? You could pause and think about that. Could you have true premises and true conclusion and fail to have validity? You might say, yeah, isn't validity about truth preservation? It is, but you can have true premises and a true conclusion on accident. So all valid arguments preserve truth, but there are some arguments where there happens to be truth everywhere, but it's by accident. It's not through validity. And we can find this on this table. So we want to look for true premises, true conclusion, but invalid. Here it is. All flowers are plants. Think about that. Is that true? Of course it's true. All flowers are plants. Yeah. Second premise. All daisies are plants. Is that true? Yeah, daisies are flowers and flowers are plants. So all daisies are plants. Yeah, all flowers are plants. All daisies are plants. Now, would it follow that all daisies are flowers? See, this is where it's trippy. It's true that all daisies are flowers. It is true. But it's not true in virtue of these premises. And how do we know this? Well, if we supplant, maybe I'm thinking of supplant because I'm reading this. If we supplant or replace these terms with generic placeholders, like all A or B, all C or B, it would not follow that all C are A. And for now, just take my word for it. But we are going to learn a systematic way to show that that is invalid. Here's an argument that's even more straightforward that makes the same point. True premise. I, Ryan, live in California. What if I said, therefore, I, Ryan, am male, right? I, Ryan, am I'm a man, let's say. The premise, is it true? Do I live in California? Yes. Is the conclusion true? Last time I checked, yeah, I'm a guy, I'm a man, I'm male. But does living in California guarantee that you're a guy? Oh my gosh, that would be weird. No, that's not true at all. So the argument is invalid because the conclusion doesn't follow from the premises. Even if it's easy to imagine the premise is true because you're just imagining me living in California, which is true. Does that imply a guarantee? Does it make it absolutely certain that I'm a male, guy, man? No, it does not. So all the combinations are here. Okay. I think it's time to practice. So let's do, sorry for the window spazzing. All right, we want 1, 4, 1, 1, 4, 1. Okay, here's 1, 4. 1, 4, 1. And you have to do all the highlighted ones, and we'll do the ones that are circled. All right, what do we have to figure out for this exercise? Well, the following arguments are deductive. Okay, that's nice. So we don't have to guess at the argument type. Determine whether each is valid or invalid. And note the relationship between your answer and the truth or falsity of the premises and conclusion. Finally, determine whether the argument is sound or unsound. And so we will be classifying the argument using the concepts and terms on this chart. Great. Here we go. Number 1. Since Moby Dick was written by Shakespeare, and Moby Dick is a science fiction novel. See, I'm laughing because I know that's not true. It follows that Shakespeare wrote a science fiction novel. I could see why the authors wrote the question like this. See, this argument is valid, but it has at least one false premise. Moby Dick, it's fiction, but it's not science fiction, right? It's a great American novel by Herman Melville. It's about Ahab chasing the whale. It's not about the future or about, technology that doesn't currently exist. No, it's about, sailing. So it's like old technology. And also Moby Dick, I said, is a great American novel, right? Shakespeare was an English author. Moby Dick was written by Melville. So this argument is valid. Why? Because if you imagine that Moby Dick was written by Shakespeare, and further that Moby Dick is a science fiction novel, then Shakespeare wrote a science fiction novel. If you grant that those are true, so are you starting to see the differences here? This argument it's valid, and it's deductive. We know that because it says we analyzed it, we found it's valid, but both premises are false. And that means the argument is not sound because if you're going to have sound, you need the validity, which it has, but it doesn't have true premises. So that's 141. Yeah, valid, unsound, false premises. Oh, and the conclusion is false. Oh, yeah, it has to do that. Okay. Did Shakespeare write a science fiction novel? Well, I mean, not that I know of, but at least the authors of our textbook, I guess. I mean, yeah, Shakespeare. I mean, I don't know. It depends how you define. We're going to talk about definitions, which are very interesting later on in the course. But I mean, I think that people who are English majors and experts in the field be like, okay, yeah, Shakespeare, he didn't do science fiction. All right, since London is north of Paris and south of Edinburgh, it follows that Paris is south of Edinburgh. So Edinburgh is in Scotland, by the way. Paris, France, London, of course, England. Now, does the logic work? Is this valid? Well, let's just at least pretend. Let's grant. Just imagine that London is north of Paris. Okay, so you've got London here, and then you got Paris, right? So here's like this end thing. London's here, and then Paris, and then the next part is that London is south of Edinburgh. So we have London, Paris here, but we said London is south of Edinburgh, which means that Edinburgh would have to be further north. So the order is Edinburgh, London, Paris. Edinburgh, London, Paris. Those are all the premises. Would it follow that Paris is south of Edinburgh? Well, that sounds right, because Edinburgh was at the top, if you will. No, I don't know if north is top, but so be it. Edinburgh's up here, and then Paris was way down south. So the logic works. Geographically, the logic works. If you grant the premises, the conclusion has to follow. So this is a valid argument. It's valid. Now, this is an empirical question. Are these premises actually true? Well, if you know a little geography, this isn't too tough. But yeah, so if you look at the UK, if you look at the Great Britain, Scotland is north of England, right? The UK is an interesting country because it's got these different parts, right? It's got England, Scotland, Wales is around there too, and then Northern Ireland, which is like not even on the same island, but Scotland is north. Edinburgh is north of London, and then you would have to go further south to the continent, if you will, to get to France, to get to Paris. So these premises are all true. The conclusion is true, and it's valid. Valid sound, just sound. Why? Because all the premises are true and it's valid. Good, true conclusion. Okay, let's go to number 6 here. The Empire State Building is taller than the Statue of Liberty. The Statue of Liberty is taller than the Eiffel Tower. Therefore, the Empire State Building is taller than the Eiffel Tower. Again, we're doing this kind of like, instead of north to south of, we're doing bigger or taller than. Okay, so we'll put Empire State Building here, Statue of Liberty down here, and then Statue of Liberty taller than the Eiffel Tower. So Eiffel Tower would have to be down here. So we've got Empire State Building, Statue of Liberty, Eiffel Tower. Now, I already know that premise is false, because the Statue of Liberty, no way that that's taller than the Eiffel Tower. So the Statue of Liberty, if you haven't seen it in person, it's not that tall. It's not that tall. Eiffel Tower is very tall, and so is the Empire State Building. I mean, like, what is tall? So it's not going to be sound, because we have at least one false premise. But if we grant that order, even though it's incorrect, if we grant Empire State Building, Statue of Liberty, Eiffel Tower, would it follow that the Empire State Building is taller than the Eiffel Tower? It would. So the logic is there. If you grant this, the logic is there. It is valid. False premise. Let's see, valid, at least one false premise. So it's unsound. Is the conclusion true? Well, it might accidentally be true. Now, this one, we'll see. Empire State Building is taller than the Eiffel Tower. Not sure about that one. Happens to be true, but has at least one false premise, but it is valid. Yeah. So Eiffel Tower, it's tall, taller than Statue of Liberty, but not taller than the Empire State Building. Okay, great. 8. Chicago is a city in Michigan. That's true. Michigan is part of the United States. That's true. Does it follow? So it's easy to imagine this being true because it is. Does it follow that Chicago is a city in the United States? Yeah, that works. Chicago is in Michigan, United States. So Chicago is a city in the US. Great. No problem. So that's going to be valid, all true premises. Validity is truth preserving. So the conclusion has to be true. And we can look at it. And it is true from common knowledge. So it's valid, sound, premise, and conclusion, all true. And yeah, we can just write that in here because I accidentally erased that one. So it's valid, sound, true premise, true conclusion. Boom. Okay. And 15. United States Congress has more members. Oh, this is the cool one. This one will cook your noodle a little bit, if you will. The United States Congress has more members than there are days in the year. So how many members of Congress are there? Are there more than 365? I believe so. So the premise is true. Therefore, here's the conclusion. At least 2 members of Congress have the same birthday. So I'd pause the video and think about that one for a second. You have to kind of mathematically think about it. And you could do it on a pen and paper, and you could say like, okay, let's say you've got, we don't know, like all members of Congress, they could all coincidentally have the same birthday, right? But they could just by coincidence, but is it guaranteed? Well, it actually mathematically it has to be. Like let's say that you would win money if no members of Congress had the same birthday. Well, so what would you want? Well, you wouldn't want any 2 to have the same birthday. So let's say you lined up all the members of Congress and you lined up the first 365. And then you don't want to lose the money. You want to win the money. So you would hope that all those 365 have different birthdays, right? And you could arrange it by, okay, well, you all have different birthdays. And then, Congressperson 1 would be January 1st, Congressperson 2 would be January 2nd, Congressperson 3 would be January 3rd, and so on and so forth, right? Congressperson 31 would be January 31st. Congressperson 32 would be February 1st. Congressperson 365, forget leap year, by the way. Congressperson 365 would have the birthday at the end of the year, which would be December 31st. Okay. But there's still more Congress people. Why? Well, because there's more than 365 Congress people. So even if you have 366 Congress people, that 366 person, their birthday, it has to go one day of the year, and all the days of the year are already covered by at least one congressperson if you spread it out as much as you can. So it's kind of cool to work that out. What we did there is it's like we did it kind of point by point, and it's funny. It's actually, when we mapped it out like that, we were thinking deductively, and there's a name for that type of, not rote, but kind of writing it all out in all the gory details, even though we kind of did some dots, right? I went from Congressperson 32 to Congressperson 365. So there was like a dot in there. I kind of skipped over, but we could spend whatever, half an hour and like draw it all out if we really, really wanted to. And when you do that, mathematicians and logicians, they have worked on problems like that so much. That method is so useful that it has a name, but it's a bit of a misnomer because it's called mathematical induction, and it's actually a form of deduction. But so be it. Things have funny names. All right, so 15, valid sound. There are more members of Congress than 365. And yeah, there would have to be at least 2 members of Congress have the same birthday. They're probably friends, hopefully, even if they're across the aisle. Let's hope. Okay. Let's go back to our syllabus here. So we just did 141. Let's do 142. Here it is. The following arguments are inductive. Determine whether each is strong or weak, and note the relationship between your answer and the truth or falsity of the premises and conclusion. Then determine whether each argument is cogent or uncogent. So it's a similar exercise. Instead of classifying the argument, we already know that the earlier set was deductive. Instead of figuring this stuff out and truth or falsity of the premises, we're going to figure these categories out for these inductive arguments. So we're going to look for strength, weakness, cogency, uncogency, if you will. Let's go to number 3 here. The vast majority of Rose Bowl games in Pasadena, California, have been played in freezing cold weather. See, I know that that's false because the Rose Bowl is in Pasadena, Southern California. And even though the Rose Bowl is in winter, it's usually in January, I believe, like around the new year. Freezing cold has a definition. It's usually, below zero. Water freezing is usually when water freezes, like when rain freezes. So that's 0 degrees Celsius or 32 degrees Fahrenheit. And Southern California in January, and the game isn't, there's the low of the day, which is probably like at, I don't know, 3 or 4 in the morning. But the games are played, 10 a.m., noon, 1 p.m. And so there's probably a lot of days where the weather's not too bad. It's probably in the 50s, maybe 60s, probably have some 70s days. So vast majority, that's false. And but if we imagine that this is true, if we look at the track record, so how many Rose Bowl games have there been? Let's say there have been more than 40, probably are. If that's our track record, that's a good track record. So we're doing an argument based on a pretty healthy size sample. And so we're talking about the next Rose Bowl game. And so I would say this argument is strong, but it has a false premise, and so it can't be cogent. So yeah, strong, not cogent, false premise, probably false conclusion. Okay, good. Most popular film stars are millionaires. It depends. Just some vagueness here. Like, what does it mean to be a film star? What does it mean to be a popular film star? Okay, let's say that this part's true. Shailene Woodley is a popular film star, therefore probably Shailene Woodley is a millionaire. This is a fine inference. I'd say this is strong and cogent. Right, because again, when we imagine this is true, well, you might not know Shailene Woodley, but she's been in a lot of very good films. She was in one called The Descendants, which was good. I like that one. You might have seen it. And this is true, probably true. This is arguably true, and this follows in terms of probability. So I would say this argument is strong. The premises are true. So I'd say cogent. Strong, cogent, true premises, probably true conclusion. People have been listening to rock and roll music for over 100 years. Probably people will be listening to it a year from now. Again, without even thinking about whether or not this is true, if we grant that it's true, I think it would make the conclusion likely. So this is a strong argument. We're definitely going to go with strong. Okay, it's 100 years ago is like 1920s, and some of you might not know the history of rock and roll, but you probably 1950s rock and roll. Sure. 1940s, stretch or no. 1930s, stretch or no. 1920s, no, it wasn't around yet. People, there's new genres that come about, and you had to get to the 50s and definitely the 60s. That's when there's rock and roll exploded. So I think we should go with false premise. Conclusion is probably true. Happens to be true, not because of the premise, which is false. So conclusion happens to be true. Premise is false. Argument is strong, right? Because even though it has a false premise, if this were true, then yeah, it would make it likely that it would be a year from now. So we want strong, false premise, which means it cannot be cogent, but the conclusion happens to be true. Strong as a false premise, cannot be cogent, but the conclusion happens to be true, probably. All right, 1-4, Roman numeral 3. So we just did practice with validity, soundness, and then we did it with strength and cogency. And now we don't know, is it inductive or deductive? And if it is inductive, then we have to figure out if it's strong or weak. If it's deductive, figure out if it's valid or invalid. Okay, so we're going to, deductive, inductive, we're going to practice a little bit. When a cook cannot recall the ingredients in a recipe, it is appropriate that she refresh her memory by consulting the recipe book. Okay, that sounds reasonable. Similarly, when a student, I see what they're doing here. When a student cannot recall the answers during a final exam, it is appropriate that she refresh her memory by consulting the textbook. I mean, if it were an open book test, yes, but presumably it is not. This is an inductive argument type, a very special inductive argument type that is called argument by analogy. You're saying, hey, look, this follows in this first case. And so the second case, which is supposed to be sufficiently similar, but it's not, it should happen here too. It's like, hey, if a cook can consult a recipe book, then why can't a student consult a textbook on the final exam? Well, it's two very different domains. And we just know that the first one's appropriate and the second one is not. So this is not a good argument. It's an argument by analogy. Those are inductive arguments. So it's an inductive argument. I would say it's not a strong one. Inductive, I would say it's weak. Okay, so that's 3-2. Inductive weak. It's like I've taught this class before. All right. Again, the ones with the stars, the answer's in the back of the book. So you can go there for the answer, or you can watch this. Since Christmas always follows on a Thursday, it follows that the day after Christmas is always a Friday. All right, let's think about that. Is Christmas always on a Thursday? Well, if you know about Christmas holiday, it floats around. It can be any day of the week, as far as I know, but it doesn't have to be on Thursday. So this is a false premise. So it can't be sound and it can't be cogent because those require true premises. But suppose that Christmas always were on a Thursday. If we grant that, would it follow that the day after Christmas is always a Friday? It would. And does this follow probabilistically? No, this would be guaranteed. So I hopefully once you've been doing this many problems, you're really starting to see the difference between induction and deduction. This is a deductive argument. Why? Because if we granted this premise, the conclusion has to follow, because Friday follows Thursday. It's just by definition of our calendar, right? This is a deductive argument, and it's valid. If we grant this premise, the conclusion has to follow. But is it sound? No, because Christmas isn't always on a Thursday. So we want deductive, valid, unsound. Deductive, valid, unsound. We're doing great. By accident, Karen, ooh, that name is not so auspicious these days, is it? Karen baked her brownies 2 hours longer than she should have. Well, she's a Karen, so apologies to anyone named Karen out there. Therefore, conclusion indicator, right? They have probably been ruined. Okay, just soak in the premise. Well, is it a guarantee that they're ruined? Now, some of you might think, oh yeah, 100%. If you 2 hours longer than you're supposed to, guaranteed they're ruined. But be careful. You have to think. You got to be creative. Is it possible? Is it logically possible for you to bake brownies for 2 hours longer than you should and them not be ruined? It is possible for them not to be ruined. Just be creative. Well, maybe the temperature, what define baking, right? If you bake something at 1 degree over room temperature, is that baking? It's a good question. If it is, then they wouldn't be ruined, and what it's like the time that the recipe says to bake, maybe the oven was on the right amount and then it cooled down to I don't know, or 5, 10, 20 degrees over room temperature, 40 degrees over room temperature, they'll just keep the brownies warm. It's not going to cook them anymore. Or what if tomorrow, or what if this Karen person invented brownies that are burn proof, right? Those don't exist now, but we can imagine it, right? It doesn't defy the rules of logic. There's no contradiction when you try to conceive of brownies that can't be ruined, right? People try to come up with products like that all the time that are sort of, that are idiot proof, if you will. So this is an inductive argument, and it's a strong one. And see, now, is it cogent? Well, this is a hypothetical. So if an argument's going to be cogent, then the premises actually have to be true. But this is a question mark whether or not this is actually true, because who's Karen? If we find a Karen who actually did this, then it'll be true. But if it's just a hypothetical, then it could go either way. So we'll say inductive, strong, cogency depends. It's a hypothetical, right? And that's why it says inductive, strong. It says nothing about cogency. Since Phyllis is the cousin of Denise, okay, Phyllis and Denise are cousins. Denise is the cousin of Harriet. It follows necessarily that Harriet is a cousin of Phyllis. No, you could see they're going for deduction. So this is a deductive argument. They're saying like there's a relationship between Phyllis and Denise. This relationship also between Denise and Harriet, and the nature of this relation is such that if A is related in this way to B and B is related in this way to C, that A must be related in this way to C. I think I said that right. A to B, B to C, therefore A to C. And in some relations that works, right? If Phyllis is taller than Denise and Denise is taller than Harriet, then well, oh no, that would actually, because of the order here, that wouldn't work. And what about cousins? Well, again, it depends on how you define cousin. But everyone, well, not everyone. If you have cousins, gotta be careful here. Okay, at least in my case, I have cousins that are my cousins, of course, but that's like just repeating myself. But then those cousins of mine, they also have cousins, like in reality. So I have a cousin, let's call him Jared. And Jared has some cousins that are also my cousins. It depends on, like, okay, so you have like grandma and grandpa, and like they have a bunch of kids, and those kids have a bunch of kids. then there's a lot of possibilities. So I have a cousin named Jared, and he has a cousin named Elizabeth. And I'm the cousin of Jared. I'm also the cousin of Elizabeth, and Jared is also the cousin of Elizabeth. We're all three of us are cousins in any way you frame it. But there's lots of ways that this might not work out. What if Harriet? I think it could work out if Harriet and Phyllis are siblings. Okay, let's just assume Harriet and I mean, there's another way to do it where Jared has a cousin that's on the other side of his family that I'm not related to, and you might say, well, that's kind of like second cousins, but no, that's not how it works. Second cousin, I've looked this up though. Well, I mean, it's all definitions, right? One, probably the most accepted definition of second cousin is if you and your cousin both have kids, not together, hopefully, right? You and your cousin both have kids. The relationship of those two children would be second cousins. The cousin of my cousin that I'm not related to, like, because my cousin has different grandparents. That's just pretty much, not blood related at all. You might see them kind of rarely, so that's what could happen here, and which would make this not work out. But the other way, I think if Harriet and Phyllis are siblings, could the rest of this work out? Okay, so Phyllis and Denise are cousins. So we'll put like Denise just kind of graphically here. Phyllis and Denise are cousins. And Denise is also the cousin of Harriet. Yes, Harriet and Phyllis could both be siblings. Yeah, and Denise is their cousin. So for example, I have a brother named Tom. We're not cousins, we're brothers. And Jared, who I mentioned before, is both of our cousins, right? Jared's my cousin, and he's also my brother's cousin. And so if you were to say that my brother and I are cousins, that would be wrong. So 8 is deductive, not valid, and therefore not sound. Deductive, invalid, not sound. We could add unsound. All right. It's kind of fun to think through these, I hope, right? So that's part, you can see that there's a lot of that kind of figuring things out, and you got to use logic. Yeah. And that's what's cool is it's an ability that we all have. We've honed it, hopefully, to a certain degree. Maybe this is we've evolved with this, but you get to sharpen it in this sort of class, which is just good for you in general. So this sort of ability, it's pretty much good for life. All right. The picnic scheduled in the park for tomorrow will most likely be canceled. Okay. It's been snowing for 6 days straight. So this is kind of tough because this is the premise. Given that it's been snowing for 6 days straight, they're going to cancel this picnic tomorrow. Now, is that a lock? Is that guaranteed? No, maybe it's a snow picnic. Maybe we're just going to, maybe it's really maybe it's like grandma, it's like one of her, she's sick and she doesn't have much time left, and like rain, snow, sleet, we're going to hold this picnic, even if it's been snowing. Right. Now, if it just said that we have to be careful. We have to be really careful. This is good. This is fun. The picnic scheduled in the park for tomorrow will be canceled. Get rid of this most likely for a second. It will be canceled. So if it's been snowing, we're going to assume that for 6 days straight. Would that guarantee that the picnic will be canceled? The answer is no. Okay, but it doesn't say that. It says most likely. Okay. It's been snowing for 6 days straight. Does that mean 100% that the picnic will likely be canceled? And that does change it a bit, but it's still not 100% that it will likely or most likely be canceled. That's just not. It's hard for me to explain why that is, the best I can do is that the conclusion here is about the future. Deduction is never about the future. Why? Because no one has a crystal ball. We don't know the future. If you don't know the future, it can't be certain. If it can't be certain, then it can't be deductive. So this is inductive. And it's good. It's a strong argument. It's not a guarantee. It's inductive and it's strong. Now, is it cogent? Well, has it been snowing for 6 days straight? Well, I mean, this is a relative statement. I mean, it depends on where it is. Depends on where this what area it's talking about. If it's talking about California, especially where a lot of the people live, this is going to be false. So it's inductive, strong. We say nothing of cogency. Inductive, strong. Great. We're doing great. Excuse me. No scratch there. Okay. Define the following terms. This is good to practice all these definitions. So an invalid deductive argument. Okay, a deductive argument is one where, like, if an argument could talk, the argument would say, I'm trying to guarantee my conclusion. That's one way to think about a deductive argument. And then it's valid if the conclusion, it's impossible for it to be false given true premises. So the definition of invalid just tweaks that valid definition. It's possible. Given true premises, it's possible that the conclusion is false. It's possible for the conclusion to be false given premises are true. Uncogent argument. Well, cogency, you need all true premises and strength. So that's kind of cool. When I put my hand here, it gets that. Ooh, everything gets, that's nice. This is a cool camera. Look, everything gets blurry but my hand. That's kind of neat. Nice. And then my face is, yeah, well, what are you gonna do? Okay. Getting delirious here. So cogency is all true premises plus strength. So an uncogent argument is lacking one or both of those conditions. So it's either not strong, i.e. weak, or has one or more false premises. Okay. How are we doing here? Okay, that was 144. Okay, all. All right, we're getting there. Okay, these are just true, false. Yeah, we've done a lot. Let's pause for now. So thanks for watching. We'll do more later.